Good evening, dear participants. Sir, can we start or we shall hold for 5 minutes, sir? Dr. Syed?
Ma'am, I'm fine here. You can decide whatever you want to do. No problem. I'm available.
Okay,
As we have only 29.
Yeah, we have only 29. We'll look for another 5 minutes, sir. We'll wait.
Okay, no problem. No problem. I can
Yes,
wait.
sir. Yeah, thank you. Good evening, dear participants. We are now in the 5th day of our FDP, and we are again delighted to invite our speaker of the day, Dr. Syed Ibrahim, Senior Professor of VIT University Chennai. I think you all would agree with me that he gave us a very good session yesterday, a practical session, which was quite interesting and impressive, and made us clear with all the topics that he had come up with. And he had introduced us to introduction to machine learning algorithms and deep learning basics yesterday with a good clarity and practical coding demonstration. And today he is with us to give us another important session on big data tools and technologies, focusing mainly on Hadoop and Spark. So, which is which is going to enrich enrich our understanding on the modern data-driven systems. So, he is. I would like to introduce him again. He is an academician with over 18 years of teaching and research experience, with more than 60 publications in reputed journals and conferences. And he has a strong global collaboration with universities in Australia. He has also enabled their students to secure valuable internships in top companies such as PayPal, IBM, and Amazon, creating also a strong industry linkage and giving the students the exposure to real-world applications to have their clear understanding and learning. And we warmly welcome you once again, sir, and looking forward to have a interesting and good learning from your end, sir. Thank you, sir. Thank you. Welcome, sir.
Yeah, thank you very much for your nice introduction. I thank participants who joined already and who may yet to join. And today, yeah, as she mentioned, we will try to understand what is big data. Yeah, small introduction about Hadoop and the challenges. Then we will move to Spark, and then logically we want to apply machine learning over Spark framework. So I am interested and eager to interact with you. I hope I will give you some information about what is that. Right. So yeah, great evening to one and all. If you have any doubt, anything, you just interact with me, interrupt and interact. Absolutely no problem. So today we will try to understand what is Spark ML. So in that, I want to give you a brief idea about what is big data analytics and why every one of us are talking about it. Then we will jump into that Hadoop framework. Is one of the framework, and we will try to understand the different components and what is HDFS, MapReduce. These are the two important components, and we have many components. And then we will try to understand the challenges of Hadoop and why Spark is required. Then some important components are there in Spark, which is known as RDT, Resilient Distributed Data Set. What is that we want to understand? And after that, we will have a small code to execute and understand how to execute the code as well as the logic behind the code. Then we will jump into one machine learning algorithm called recommendation system algorithm. Recommendation system, we want to build a small recommendation system using Spark framework. So this is all about the objective, what I have with my mind today. So let us start with big data analytics. Actually, I want to start with the big data first. It's not about analytics, it's the big data. So what makes the data big or big data? Can you give some clue, some of you? According to you, what is big data?
Large
Am I audible?
information about the data.
Sorry?
Large information about your data.
Large information about your data. Okay. Any other definition? Okay. So we have data. If you say data, it's actually always it's a big. So, but nowadays we are talking about big data analytics. So there is something special. The special is on why we are calling that as a big. Okay. So sometimes we are saying like it's because of the size. If you ask me, are you saying something as a big data because of the size? Sometimes yes, it is always yes. At the same time, I have a small data, but the data is very complex in nature. Meaning is I have a genomic data. It may be size wise maybe about 1 GB. It is not big size, but it is very complex to understand, analyze, and do some computation over genomic data. So on the time we can say, hey, it's because of the complexity of the data. So we can consider data size or complexity, or in other words, they have mentioned about V's, different V's, volume, variety, velocity, veracity, those kind of V's are also available. From that also we can define some data as big data. And we this actually we will take this big data, and the next component will be the big data analytics. How it is it a new in our current trend? Actually, whatever we do as the analytics, we will do here also the same way. The machine learning we will apply here also. The learning algorithms, whatever we know, we can apply over this. But we will change a structure of it to work on this big data framework. So we call that as a big data analytical framework. And here I want to give you another some a small definition on how to define a big data. So here the data is have outgrown the storage and processing capability of a single host, then we can call the data as big data. That's a very small and simple definition to understand what is big data. That's meaning is actually if we have a normal system, say laptop or desktop, or I can say mobile. For mobile, I can store some data. So your nowadays we have about 1 TB storage, something like that. So I can store up to 1 TB. If I have a 2 TB data and if I'm not able to store it in my mobile, then that data is not a big data for mobile. But it is not big data for my laptop. Madam, can you please mute yourself? Madam, can you please mute yourself and talk? Yeah. Thank you. So if the data is actually grow over and yeah, a single system, then we can call the data as big data. So here we want to understand how long it will take to read 1 TB data. Okay. So if I use a one hard disk and I want to transfer the data from one hard disk to other hard disk, and assume that the transfer speed is about 100 MB per second. Okay. In that case, what will happen is if I use one hard disk to one hard disk, if I share the data, if you read the data, or if you transfer the data, it will take approximately about 3 hours to complete the transfer of 1 TB data. With the assumption that we have over 100 MB per second speed. At the same time, if we go with 10 hard disk, meaning is you have about 1 TB data, and that 1 TB data is spread across all the 10 nodes. And then you want to transfer those 10 nodes data into other 10 nodes data. On the time, what will happen? It will take only 20 minutes. The same way, if you use 1,000 hard disk, that is meaning is the 1 TB data is spread across 1,000 hard disk. And if you want to transfer the 1,000 disk data into another 1,000 disk data, it will take less than 10 seconds. So from that, what we can understand is if you distribute the data into multiple nodes, then the speed of analyzing or speed of accessing and analyzing will be high, too fast. So that case here, we saw that 1,000 hard disk will take only less than 10 seconds. You see the difference between 3 hours to 10 seconds, where that you can find that huge gap here. So now, what we want to understand from this, we can understand is the data needs to be stored in a distributed environment so that we could be able to access the data. And then the next one is we want to understand how those distributed data can be how that can be analyzed, or that how we can do the computation to get an advantage from it. So that there are two challenges: how to store the data in a distributed environment. That will be the first challenge. And the second one is how to work on the huge data, which is we already stored in a distributed environment. So these are the two important challenges. If you are able to answer these two things, if you are able to provide the solution for these two problems, then it will become a big data framework. And other than that, it's not just about storing the data and working on the data. We want to get some kind of analytical output from the given data by using that ML algorithms or AI technologies. AI techniques we have to apply over that this big data to get some kind of knowledge. So if you do that, then in that big data will become big data analytics as we are able to apply analytics over that big data, and we'll get some kind of knowledge from the given big data. Right. So first we want to understand what is the Hadoop and why we call this one of the framework, or otherwise Hadoop is known as one of the framework for big data analytics. Why we call this as due to two components, the main two components. One is we have Hadoop distributed file system, otherwise known as HDFS. Another one is called MapReduce. It's a programming. So as I already mentioned, there are two fundamental challenges. One is how to store the data in a distributed environment. The second one is how to do some computation on the data which was stored in distributed framework. So to answer these two things, here in Hadoop they are using two components. One is Hadoop distributed file system. This is mainly for make the data distributed, and by using this framework or Hadoop, the component, I should say component, this component will help us to store the data in a distributed environment. The next component is MapReduce. This paradigm is the programming paradigm where it will work on the distributed data, and it will apply the logic called MapReduce logic, and it's a processing environment. So it will apply that logic and it will give us the result. So now this logic will work on, it will work on the distributed environment. So that's the advantage. So we want to understand what Hadoop distributed file system, which is storage, and another one is programming paradigm. We want to have a MapReduce program. So now what we have to do is we need to write all the machine learning algorithms in this MapReduce framework with the logic that how that program should be distributed across multiple nodes, and that way we have to write it. Another thing on this kind of distributed programming is here, the one logic here is we want to send the program to different distributed node to do the computation. In those days, we will have a centralized system. Each and every node will send their data to the centralized and they will do the computation. What will be the problem? If you send all the data to centralized, we need a huge kind of bandwidth to send the data. But if you send a program to one place to other place, the program size may be very small in size. So sending the program will not be a problem. So in that logic, the MapReduce will work. We will develop on one program. That program will go from one place to other place in the distributed environment, and it will execute. So for that only we need to understand about what is Hadoop distributed file system and what is MapReduce programming environment. So here I want to show you that the Hadoop distributed file system framework, where say for example you have some two different data files, data 1 and data 2, which is stored in a Linux file system, and that data we have to share it with or we have to throw that into Hadoop distributed file system. If you do that, what will happen is the particular data will be, rather than store as the whole data, the particular data will be, it will be the system will make small chunks of data. Say for example, block 1, 2, and 3. And for data 2, it will be it will divide the data into two parts, say based on the size. Actually, generally they will go for the block size of 64 or 128, and accordingly it has two blocks. Now, what the now this Hadoop distributed file system, what it will do is it will take the data, and when you store the data 1, automatically it will make the data into 3 blocks, and it will try to store it in 3 different nodes. The same data will be 1. Here also 1, and here also 1. In the same way, 2 is replicated here, here as well as here. Why we are doing this way is actually it's, you are working on a distributed environment, and there is a chance that the system, particular system may get failure, or that system outage may be there. To avoid that, we want to replicate into 3 places. Even if you are not able to access one system, the same data will be available in other systems, so we could access it. Say for example, if you want to read data 1, how the data will be read? The system Hadoop distributed file system will take the block from 1 from here, block 2 from here, and as block 3 is not here, and block 3 may be taken from here itself. So combine all the 3 blocks, 1, 2, and 3, then it will give us the data 1. So that way, is able to take our data, make the blocks, and store it in a environment. So now, I hope you are able to understand what is Hadoop distributed file system, how the data is stored. The next one is we need to understand about what is MapReduce and how is actually working on this environment and what is the advantage and challenges. So, for example, here I want to show you one small example, which is very hello world for Hadoop. It's known as a word code program. So, in when we start with this, we have to write the logic as it should be an independent program so that it can go to any of the system and work in a parallel way. So what we have to do is we have to read the file name and its file content, and we want to throw each and every word as one. So we should read the word and that it should say the count as one. So that way, every one of us can give the, every node can give the word and the particular count as one. And with the, okay. And we have a common called reducer. What the reducer will do is, it will take the particular word and the different values. It will collect the values from different nodes. Say, for example, if I say 5, as I'm the one of the node, I'm saying 5 times. And you may be the another node, you may say about 3. Another one may say about 5, something like that. So it will take all these values and it will work on the loop in such a way that sum equal to sum plus value. So all the values will be added here, and you will get finally you will get an answer as the combined answer. So rather than doing it in a sequential way, this MapReduce program can execute parallelly across multiple nodes, and you will get an answer shortly and very quickly, as well as the correct answer will be given in a proper way. So this is the example I want to show it to you. Here, this file, the particular statement is available in one system, assume like that, and another system. So the first system will say hello one, world one, by one, world one. And then second system will say hello one, Hadoop one, goodbye one, and Hadoop one. So what will happen now? Here we have words, and the particular word will be taken hello, and here the count is one, and here count is here is one. Its value is one. Here also value one. So these two will be added, and you will get the result as hello. The same way, world here one time, here one time. So here itself it will be 2 times, and here there is nothing. So world will come as 2 times. So something like that, each and every word will be added in the reducer part, and you will get the results. Okay, is there any doubt till now? Just now I mentioned about Hadoop distributed file system and MapReduce programming. So with this, I'm able to complete what is Hadoop. Hadoop framework. Is there any doubt?
No, sir.
Okay, let me go with the next concept. So in Hadoop file system, in Hadoop MapReduce, what we will do is we will take some input which is actually available in the hard disk, and then it will try to make number of maps based on each block. Say in the initial stage, I said that data one is divided into 3 different hard disks, there are 3 different nodes, and 3 blocks. So on the time, 3 different systems, and each system will create multiple one block for each of its data, and multiple map blocks will be executed, and then multiple reduced block also can be executed based on the size of the data, and finally you get the result. And this is the general process. When we do the data processing, something like our machine learning algorithm and all the other algorithms, we know that it's a iterative process. Say, for example, if you use the clustering algorithm, it requires multiple iterations to complete. But the problem in the Hadoop system is that first the data will be available in the hard disk, and for the first iteration, every data will be loaded and it will do the activity. Then those data needs to be stored in the hard disk. Then again, the second iteration, we will read it back from the hard disk and do the iteration. Again, we will store it. This process will keeps on going. And here the challenge is, as we are dealing this with the hard disk, we already understood that as it will take a lot of time to read the data and write the data. Okay. So the same way, if we do the some query, for each and every query, it needs to get the data from the hard disk, and again it will store the results in the hard disk. So now the recent framework, they want to avoid this. So how they want to avoid it? They want to bring a framework called a Spark framework. which is known as in-memory cluster computing for iterative and interactive applications. Nowadays, IPython, we are very much useful. We using that IPython. So this, the Spark environment build those kind of IPython notebook, IPython environment. So from this only they are started integrating that Python with IPython. So here what will happen is you can interact with the system, you can change the values, and immediately you can see the result as IPython notebook, but which was not possible with the Hadoop framework. The second one is it is a in-memory cluster computing. In what way it will avoid the hard disk. It will make use of the primary memory to do the computation. So here that logic will be something like this. It will take the data, input data, and it will do the iteration. Am I audible?
Yes, sir. But the presentation is not visible,
Okay.
sir.
Yeah, Saturday my connection is okay. Okay. Right. So now in yeah. So now same way, if you want to do some kind of processing, the data will be taken into the RAM, and all the other is able to avoid extensive way. We are make use of the RAM. So we know that RAM is very fast than the hard disk. So this way they are able to do the computation is actually fast. It's because of the in memory, and other than that, a lot of other advantage also they bring in. I will show all these things in the coming slides. But at least the first impression is rather than hard disk, they want to use the RAM. Definitely, it will become fast. So we have option. We can read, we can evaluate, print, loop, and we can do all the activities in the same window as same as IPython notebook. So it will give us a clear, we can update, we can change the parameter immediately. We can execute and understand how it begins. So that way it is interactive to us. Right. Let us go with our notebook. We'll try to execute some code and then we'll come back here. This same thing I will explain in that particular notebook. Ma'am, Vaishli ma'am, have you shared that?
Yes, sir. Yes, sir. I have shared.
Oh, thanks. I hope all of you loaded this file. The named Spark ML, maybe new file, something to you. It's my thing. Can you please let me know one or two after loading it? Please confirm so that I can move forward. I can take it up. Are you able to load the file? Can anyone?
Yes, sir. One participant replied in chat.
Chat, okay. We could not use the chat here. Okay. So one more, at least I need one more confirmation so that I can start. Shall I continue? Okay. So here what we are doing is we want to download that Spark from the repository, and then we want to extract and then install it. So if you see that Spark download, this is a Spark web page, and here you can go here the download page and see we are using the version 4.0.1, which was released on September 6th. Oh, just 3-4 days back, correct? Ego. About last 6 days ago, they released 4.0.1, and we want to experiment that here. So we want to download 4.0.1, which is the recent one, released September 6th. Here we want to download it, and you can. This is, I have integrated this with IPython notebook, so just you can execute as you are executing a Python notebook. So now it's downloading. So here we are setting up Java Home and Spark Home. Java is important for executing Hadoop framework. So in internally, what we want to do is we want to store. We use the storage as Hadoop framework as a storage, and the execution we will want to execute as the Spark comments. So that is the thing. And here we are installing, and we want to see whether that environment is set up correctly or not. And here we want to install PySpark. It is what it will say is it's a Python based code. So we can write the code in Python based code, and that can in turn it can run it in a Spark framework. So that way we want to develop the code, and we want to download this also. Are you getting the download? Is it downloading in your system? Is there any challenge? Is it okay?
Do I have to get the download link?
No, not
No.
required to download. It's just I showed you. No need to do anything. Close it. Just close it. Use everything here. Execute. Just execute this Python notebook. IPython notebook.
Okay, sir. Okay, sir.
All the commands are given already. Yeah. So Python Spark. Python is also installed successfully. No problem now. Then here we want to go with creating Spark session. And we want to create a session and initialize some of the attribute, and from that we want to work out some of the activities. So here we are passing the data, Alice, 25, Bob, and Charlie, something like that. And here we want to make that as a data frame. So we want to create the data frame as data and name and age. So this way we want to show the data. So it is able to now we want to show the data frame. Here able to say name and age and these three things in a data frame. The same way we want to create another file, and here we want to show that as a okay. Is there any doubt till now? Are you able to execute?
It's running, sir.
Okay. So now from here, I will take you to the next level. It requires some kind of understanding. Can you please note it down? Here we are sending some data equal to 1, 2, 3, 4, 5, and we are passing that to the data one. And here we are parallelizing the data. So when we parallelize it, it will become a Spark data. Then we have to use some specialized commands to execute a Spark command. Do the activity in a parallel mode. So actually, whatever we are trying here is a single node. As we are using the single node, it is working in a single node. But the same way, we can have a distributed environment. We can set it up, and we can pass the data, and we can execute from any one system, and all the execution can happen in a parallel way. Okay. So here we want to see there are this here we are parallelizing data in the name of VA. And here we want to see to understand it's a collect is a command called just printing the data. So here we are able to see those data. And here we can see A.top2. What could be the answer here?
It is showing as 5,4.
Yeah. Why it is coming as 5,4? We are saying like the top two elements. So the data will it will throw the data as 1, 2, 3, 4, 5, and the last two elements that is known as top two. Those elements are coming up. So take will give us first three elements. How many elements we are giving? That many elements will come from the first. And yeah, first element is of the first element what we throw, and count will give us how many elements in the thing. And from here, we want to understand some of the important concepts. Here, the Spark is having some other concept, and we want to understand it. Okay. Right. So just now we have taken this kind of code, we pass on some data, and we parallelize it, and then we are able to collect it. And after executing this command, we got the output of something like this. So all these things we already we can give a try, but how it takes it and what is the uniqueness of passing these kind of commands, actually that we have to understand. Here, each and every command, whatever we pass, it will work in the environment called RDD environment or resilient distributed data set. Whatever we pass, it will come under this logic. So what is this logic, or what is resilient distributed data sets? Here, it's a distributed environment. So what is the problem is we have to make all the data immutable, as no one else should not update randomly. No data should not be updated randomly. So what happened is each and every data, whatever we do in the activity, it automatically converted as immutable thing. So that is the first concept. The data will become immutable data. So whatever you pass, it will become immutable. What is the meaning of that? So here you are you have a variable called A, and you can't save another information in the A as of now. That will not be allowed here. Okay, that is known as immutable. Another one is resilient. Here, all these activities are happening in a distributed environment. So sometimes, or most of the times, the data may lose. Why it is losing? Actually, it is follow. We already just now we saw about the Spark will replace the RAM as the primary source to do the activities or interactive activities or iterative activities. So the output will be stored, and then for the next loop, it will take the data from the RAM and do the activity. Sometimes those kind of data may lose. So on the time, what it will do is it's a concept we can. This is a fault tolerant. So what it can do is even if the data is lost in BitTV, it won't worry about it. It will go back to go back to one step ahead. I mean one step where it will try to execute the same command again. get the result, and it will start with the next activity. And all the data is actually distributed across multiple nodes. So by this resilient way, it will recover the data if any data loss, and if it can do the activity in a distributed environment, and all the data is immutable. So this is the basic logic or basic concept behind Spark. It will each and everything will be considered as resilient distributed data sets or RDD. That will be the core component of the Spark. Okay. So now it has other properties also. This program is actually lazily evaluated. All the programs are lazily evaluated and type inferred. Can you tell me what is lazily evaluated? Any idea? What is lazy programming? Okay. Some of you may be in the online. Now tell me, then I will give you one quiz, and you have to give me the answer. Can you reply in chat box, at least say, yeah, I am interested. Yes, why, at least why, to mention that you are interested to do this quiz. Small quiz, 1 minute quiz. Only one reply as of now.
Sir, the delay in evaluation is called as lazy programming, sir.
Delay in evaluation. Okay. Right. That's okay. Good. Now tell me, how many of you are interested in quiz?
Sure, sir. Sure, sir.
For 5 reply, I got 5 replies. Another 5 at least. 6, 7, 8. Okay. Right. About 10 of them are interested. Now your time starts now. I will show one small part of the code, and you after I will execute, and then I'll say, hey, you can answer it. Then you have to answer. Okay. Who will answer first? Then I can say a big hello to them. They can do that, or Dr. Wisely can send some chocolates to you. I don't know how she will send it. Okay, let us start the quiz. Ready? Are you ready? Yeah, you can answer now.
Sir, A is equal to 1 crore, sir.
1 crore. Okay. Someone is saying 10. Priya 10. HOD madam, Wisely ma'am, I think she is saying 10. Nagajodi 10. Gangadevi 10. Lakshmanan 10. Everyone is
10
saying
crores, sir.
10.
B is 10 crores.
10 crore. No. A equal to print
C,
A
sir,
only.
C, sir. So
No, I
print
don't
A.
want C. What is the value of A?
A is equal to 10, sir.
That's it. Okay. What is the problem? When I start like this, everyone created some memory and allocated memory A equal to 100. Then you allocated yourself the memory and have some 100. Then you did all this kind of computation. You did this computation and this, all these things. And end of the time, I need only A equal to 10 and print. What about all this computation? Is it useful or waste?
Invalid.
It's like variable, sir. It is changeable.
No, it is not changeable or not. I don't care about it. As what about this, all this computation? Whatever you did, is it worthful?
The last one is the
No, sir,
important thing.
it
The
is
other
not
things are
worthful.
not needed.
It's
Not
not
worth.
useful at all. And here we have A equal to 10, print A. All these things are not required at all. But what we did, we have created the memory, we did a computation, here also another computation, this computation, that computation, and finally we wasted our resources costless computation. But here the requirement is this. Are you able to understand? This is called lazy programming, where here the lazy is, it will wait until if there is a it will wait until when we it will wait till uh, it will wait and whenever there is a requirement, then only it will do the activity. It won't create the memory, it won't do the computation. Whenever there is a requirement, it will do the computation. Here, according to this program, where is the requirement? According to this program, which one is the required thing?
Last
A equal
two
to 10
lines,
and
sir.
20A.
Last, don't say about last two lines. The last line is the important one. I want to print A. So if you want to print A, then it should understand where is the value of A. Where is the value of A?
Before.
Last
A
line.
equal to 10.
Previous
A
line,
equal to
sir.
10. That is
Before
enough.
print.
So rather than it comes from top to down, it will go bottom to up. Meaning is whenever there is a requirement, here is the requirement is we want to print A. That is known as the concept. So that to do that, what is required? I need some value. Am I getting that value? It will go upwards. It will try to get some value. If it gets the value, then immediately it will print. So this is the difference between eager programming versus lazy programming. The Spark will work as a lazy program. Our C and all the other programmings, actually they will work in a top to bottom. So they will be wasting all the resources. So are you getting it? What I'm saying? So now this laziness is actually an important concept in Spark. It will do the computation only and only if there is a requirement. So what is that? Here, these some of the RED functions. These are the transformations. We will use all these, some of them in our sorry, executing our command. And these are the some of the commands which is known as parallel activity. And these commands alone known as the the parallel activities, which is the based on this command only all the other computation will happen. So, for example, I will come back to this later. Collect. Okay. Let us see the collect. Actually, this is known as action. Based on this action only, all the other computation will happen. So please try to understand there is something is known as action. That action is nothing but in our program, print A is the action. The remaining things are known as transformation. That is changing the value from one place to other place, or that one variable to other value, assigning it, that doing all these things. So that will be known as transformation. And this kind of activity, that is print A and do some kind of activity, is known as it's a action. So actually print is not available in Spark. Rather than that, we have a concept called collect. So when we see that command, say for example, we executed this command, list data.3. Okay, here the take is the one of the action. So when it sees this command, then only it will do the activity. Otherwise, it won't do the activity. It will not try to understand what is the meaning of the data and list data and all the other things. Am I convey the meaning? Are you able to understand what I'm talking? Is there any doubt? Okay. So that way we already executed some of the commands. Here I used a variable called destiny data. There I used the data, I guess. Okay, all these things are fine. Now, so we saw about some important functionality of Spark, which is known as laziness. And now we want to see another important functionality of the Spark, which is known as lambda operations. So even some of you now nowadays, actually the lambda operation is very common across all the programming environment, including Java and Python. So I hope many of you know so about it. However, it's my responsibility to say about this. And here, yeah, here we will use as the functional programming. This can be used as a functional programming, where we can have some functions, and here we can define the function rather than it's ordinary programming function that we will write about 4 or 5 lines. Say we will say for loop, and then inside we will say some kind of activity, then summation is equal to sum plus I, something like that. We have to define 4 or 5 lines. We have to write it as for the function. But nowadays, it's functional programming is picking up, and this is Spark is also one of the functional programming where you can define some function in a single line. So here we are defining the function in such a way that if you have some elements, these 2 elements need to be added, and then the next element will come in, and then it will be added. Say for example, here we had a value of 1, 2, 3, 4, and 5. Those are the values we have. Okay, so our objective is to add all the elements. So what it will do, it will start with in an iterative way. It will start with the x and y as the 1 plus 1 is the x value and 2 is the y value, and it will add these 2 value, and that value will become x. This output of this will become x, and the next element will become y. Okay, so the same way, this element will become x, and our next element will be y, and this element will become x, and this element. So now we are come to the end of that last element. So what will happen? The loop will execute, and then loop will go over, and you will get the answer as 15. So we can have we will be able to write functional things in your Spark environment, and it's a lazy one, so it is faster enough, and it has you can get a better result by using a few lines of code. So these are the advantages of using the Spark environment. Okay. So now what will happen? Here we are using the map as one of the transformation. By seeing that line, there is no action will happen. Okay. It won't create any space. It will not do anything. It will watch. But after seeing this, what is required? Collect is one of the action. By seeing this action, what I need? I need mapped data. Where do I have mapped data information? Yes, I have mapped data information here. What it should do? It should do map the elements of this x should be multiplied by x. So it's a functional programming. What will happen? My 1, 2, 3, 4, 5 is the input, and I will get 1 as the out 1, 4, 6, 1, 4, 9, 16, 25 as the output. As what we are asking is we want to square the elements. Okay, so that way we will get a answer. So now I am talking about map. Okay, map, and next we will try to understand some of the other functionalities also. So this will work in the same way. Okay, now here we have some map and flat map options. Here we are in a functional way. What we are seeing is x and x plus 5. And here if you collect, you will get each and every combination of elements in the map. And flat map will give the particular logic across all the elements. So the flat map will be highly useful in Word documents and something like that. Okay. So any doubt till now? Is there any doubt? Okay.
Sir, the single line program is little hard to understand the logic.
Oh, okay. I will give this again. Sir, if I ask you to, I gave you 5 elements, 1, 2, 3, 4, 5. And I asked you to write a program, C program to add all those elements. How will you write the program, sir? What could be what may be there in the program? What are the elements will be there in the program?
There will be list, and I'll be calling in a loop. I'll be calling and I'll be adding this.
Correct. So you have to write one line to read it, then another about 4 or 5 lines to write the function in such a way that you will say function of something like that. Then you will go for the for loop for I equal to 0 to 5 or 0 to n, whatever it is. Then you will add sum equal to sum plus I, and you will get the result. How many lines you have to write the code?
Like 4 or 5 lines.
5 lines or 6 lines. It's a very simple thing. We want to write 5 lines, 6 lines. But by using the single line, we are able to mimic the same thing. So what we are saying here is here lambda operation And here what we are saying is x comma y is given as x plus y. So if I give you two elements, these two elements needs to be added. And this should be executed across the elements. So that way the particular statement will give the instruction to the system. So what will do? It will start with the first two elements, 1 and 2 will come, and these two elements will be added, and you will get a 3 as the output. Agree up to this? Are you agree up to this? Are you able to understand up to this?
Sir, there is a slight x comma y is 2x plus y, right? So
Yes.
x and y is representing two elements, first two elements,
Yes.
right? Then x plus
Yes.
y is adding the first two elements.
Correct.
But why? How is it being assigned to x again?
That is the logic behind it. Actually, after adding it, you will get the result. No, that will become an element as x. The next element, this element will become y.
Okay.
Okay, you will get the 6, and this 6 will become x. This 4 will become y. 10 will become x, and this 5 will become y.
Okay. So x comma
Sir,
y.
sir, but where we have mentioned that it will start from 1 and it will go up to 5.
The lambda talks about the elements. The elements available in it meaning is the simple word will say the logic should apply on elements in a given list. So what is there in the list data? We already gave list data as 1, 2, 3, 4, 5. We just executed. No, I can show it in the sheet. Okay.
So what is the
We are
function
here.
reduce? It is calling inside reduce, right?
Yeah, reduce is the function to do how we want to reduce it. The map reduce logic we saw, no? If in Hadoop programming. So in the reduce meaning is we want to reduce the components, and with this logic. What is this logic? We want to add all the elements.
Maybe few more examples I will be able to understand. Sir. It's okay. Let's
Okay,
proceed.
no problem. Now what we can do is we can have one more code, and
Sir, it means that the entire list is reduced by adding all the elements.
yes.
Okay. Then suppose if we instead of x plus y, we can mention some other functions which can reduce the entire elements of that list to single value.
Correct. Here you got the result. X into y. I multiplied all the elements. 1 into 2. Then that element will be multiplied by 3. Then that element will be multiplied by 4. And the output will be multiplied by 5. You got the output 120. Got it?
Okay, sir. Okay, sir.
Okay. Divide is not possible. Why? That will not give us. It is not a sequential function. So that is not possible. Minus is not possible. But the plus, multiplication, all these things are possible. It's the associative property, which is having associative property is possible with the lambda operation. That also we have to understand. Is it okay, guys? So it's it's compressing. Nowadays, actually, we are compressing the logic into small 1-line code and 2-line code, because only we are able to execute a lot of things in a small few lines of code to have a lot of
Sir, there
big
were
program.
2 more examples you have given, right?
Yeah, here I gave that.
No, not this one. And that PPT.
Okay.
Yeah.
Are you talking about this?
Yes, sir. This one.
This
mapping.
One? Okay.
Yeah, mapping is doing.
Okay. Here we can see that. Now map. What we are saying is the map. Okay. See, I said that there is a transformation and action. Okay. If I execute this, will you get any answer?
No. After giving collect only, it is going
collect only we will get it. But the reduce is the action. As because of the action only, immediately we get the result here. But if you execute that, you will not get any answer. But and it will not create any memory, it will not do any kind of action. But now, because of this m.collect, it will do the action. That I hope you are able to understand now. Right. Now, what I am saying, take the a value, and x should be multiplied by itself. So a value, first value will come, that value will be multiplied by the same value, 1 multiplied by 1, you will get the answer as 1. Then second element, 2 multiplied by 2, you will get 4. Are you getting it at this point?
I'm okay, sir.
Yeah. So now we are going with the next element. Here all itself I could explain. So now we want to parallelize we are passing some data, apple 1, orange 5, apple 6, and all those things. And here we want to see the keys. So if we pass these kind of elements, say one character and with one numerical value, this will we consider as key value pair. So what we can do is we will go with the word count program or even the map reduce program with the concept of key value pair only. So here now what we are passing is we are passing apple 1, orange, something like this, and we want to see only the keys. So it shows me the keys. Okay. The same way we want to see the values. Okay. So I am getting the values as 1, 5, 6, and 3. These are the values. Now we already know that some logic is map logic and then reduce logic. Now we want to integrate these two logic into our program so that it will become map reduce logic. So map will do the logic in such a way that whatever you are giving as the input, it should map with some the logic, and then reduce should add those values and give that value. Okay, the word count program we saw no, so that that only we will try it now. Right. So here what we are doing, here we want to pass some data called hello VIT, hi VIT, welcome VIT. Now this needs to be counted. That word count program needs to be applied here. And I need to get the answer such a way that how many times hello is occurred, VIT is occurred, hi occurred, and welcome and this way. So what we are trying, we want to separate the line by using the space. Okay. So if I find some space, then I can consider this as a line. So that logic we are applying here. And that way we want to say, hey, it's a mapping for throw the output as word comma 1. Whenever you have this space, send as the particular item as the word and say count as 1. Okay. So what it will do, it will give us some words after reduce by key and collect format. What it will do is here it will go with the logic. Okay. So for each key, I already mentioned that what is key. So each and every element will become key, and the number of times it occurred will become a value. And now it will reduce the particular key by its value. So what will happen? Hello, welcome will come in 1 time. Hello will come for 1 time. VAD occurred for 3 times, and hi occurred for 1 time. So this way it will do the key value pair, and map and reduce concept is applied on this. Any doubt?
So this is the new logic which is introduced.
It's a map reduce logic. So I think you missed that Hadoop example, maybe. Okay. This is a map reduce logic which used to find the number of occurrence of word. So word count program or hello world, it's something like hello world program for Java. Generally, we will use this word count program in Hadoop framework and Spark framework to understand how it behaves. Is it giving you some idea about how that map reduce works? How this, if the same program, if you want to write it in the Hadoop, you have to write it about 100 lines. 100 lines of code is required in Hadoop framework. But here in Spark framework, we used only about 4 lines, 5 lines to complete the logic. Actually, I did multiple prints here. Otherwise, it's not a problem. You can 4 lines is enough to get output. Is there any doubt? You able to understand? You able to get some logic behind it? Okay. So now we are able to understand what is MapReduce logic, a basic program. We are able to understand the Spark framework. Now my responsibility is to give you some machine learning thing in the Spark framework and how we can execute and how to understand the logic. So all these things we already tried now. Right. So now till now what we saw is how to handle big data. Then this will become big data analytics one and only if you incorporate analytics into this. So generally analytics is all about introducing AI into this and machine learning algorithms into this so that your algorithm, your data will become knowledgeable thing. We have to extract the knowledge. To extract the knowledge, generally we will use machine learning algorithms as you are very aware of it. And generally it's again, I want to give you some small understanding. It's you have a training data, we will have a data, we will take the data and we will divide the data into training testing. We'll do the training testing, and by using the training data, we will apply some learning algorithm, understand, and it will be iteratively to learn, and then finally you get the model with the level, and then you will use the tested data to ensure whether that model is working properly. So this the cycle behind the learning cycle behind the machine learning. The same thing here also we want to apply in our Spark framework. Okay, so what it will do after applying the machine learning algorithm on this big data, your big data now hereafter it will become big data analytics. So we want to apply analytics algorithms on this big data. That is the logic behind the current session. I will take another 10-15 minutes to show you how this recommendation system is one of the machine learning algorithm, how we can make use of this recommendation system algorithms in our big data framework, Spark framework, and how we can execute the recommendation system algorithm and how to get the results and what is how to interpret and all those things we have to see. Okay. So when we see the recommendation system, this is all about the small presentation on what I will say in this current thing. The first objective, then I will give some introduction, and we will try to understand what is recommender system, and we will try to understand what are the different types and what is the problem and what is dimensional reduction and how this Spark can help us to avoid this dimensional reduction. This is all about the objective now. So some of you may not, you may hear about this recommendation system right now, but you already used it. If you go into Amazon or Netflix or Flipkart, wherever you go, you will get a recommendation. If you buy something, immediately another item will come into in the bottom. It will say, hey, some of them who already purchased this, they already purchased this also, these items. And that way they will give you some recommendation. Or even if you search something in the Google and if you go into YouTube, you will get the same kind of, those information as the advertisement in that. So those things are actually recommendation. Okay. If, in a simple way, if you buy something and then some of the associated items will be given as a recommendation and it will tempt you to buy it. And because of that will improve the business of the particular company. And some Netflix, Google, and Amazon says like about approximately 30 to 40% of their profit comes from this recommendation algorithms. And Amazon is the one who initiated this or developed this recommendation algorithms. And nowadays, every one of us are using those algorithms for different purposes. So how it will work is the data set should consist of users and items. So we can consider this Amazon as a base so that we can understand it very clearly. And you and me are users, something like millions of users are there. The same way it consists of millions of items. Now it should do some activity with respect to user and item. It should do some kind of combinations and it should give us some kind of recommendation for each and every. So how it will do that we have to understand. First, it will get a user information, user profile. That is all about when you start using that Amazon, it will ask about your age, gender, your location, and it will try to understand some of the other parameters by having some information with you, interacting with you. And the same time, the item information should be available and the user information will be available in the system. These three are the input. And based on these three things, the system will be able to do some kind of analysis and it will give some recommendation. And even Facebook is doing friends recommendation using this logic only. Okay. And when we go with the recommendation system, we have three types. One is content-based, another one is collaborative-based, another one is hybrid. So it's a hybrid is nothing but combination of content and collaborative. And in the content-based, what we will do is we will have some recommendation based on the description of the item. Say, for example, we will give some review remarks, and the items will have some kind of description about the item. So when you give the review, and they will try to understand what kind of review you are giving, they will try to get some kind of keyword, and based on the keyword, they will give the recommendation. This is all about completely on content-based. Another one is collaborative based. In collaborative based, they will see me and you as is there any similarity between you and me? That's meaning is they will try to see the similarity between the users, or they will try to see the similarity between the items, and based on that they will give the recommendation. Okay. So what will happen is in our computer science perspective, it has two things. One is prediction. So we have to predict what could be the rating we may give to the particular item. That kind of prediction it should do, and based on that prediction, it should give the recommendation. Say, for example, the rating. What could be the rating you will provide to the system? That kind of information they want to understand. Okay. So now some methods here. Assume like it's me and it's someone of your friend and you yourself, and I purchased some of the items. I purchased all these items, and now assume if you have a similarity, something like me. Meaning is if you buy item number 1 and this item also, and you didn't buy grape as well as orange that way, but your buying behavior is similar to me. In that case, what will happen? As we are both of us similar, this item will be given as a recommendation to this guy, and at the same time, this also given as a recommendation to this guy. As you are very similar to me, whatever I already purchased, as you are not buying those items, that item will be given as a recommendation item to you. Okay. The same way, if they will go with item based. In item based, what they will do is they will try to understand the similarity between the items. Say, for example, grape and watermelon is associated item in some way. Some of them are purchased this. Okay, all the three of them are purchased the particular item. But if you see this, only two of them were purchased. So one, this guy didn't purchase till now. This item will be given as a recommendation to this guy. So that way, it improves the business. Who are all needed that the system should be able to understand, and that will be given as a recommendation to the item, the users. But when we take this, it's actually a very complex activity, and it has sometimes we will use a clustering algorithm to reduce scalability, address the scalability, or else we will go with the dimensional reduction. And here the dimensional reduction we will use that some support vector machine, singular singular value decomposition, or alternative least square method. That is all about some matrix factorization method. In what way is actually we have a matrix and we want to understand the particular item and combination of user and item. So what we want to do is rather than using this very big table, we want to convert that into two different matrices of small size. So it's a compressed one. When you want to see this, you just multiply this value to this value, you will get it. So the huge matrix is actually taken in as a small matrix of two different size, and this will enough to give the original value. So that way we will factorize the component, the matrix factorization. This is all about the matrix, and we will factorize it, and the combination of these two, multiplication of these two will give us the original value. Okay, so we will use that singular value decomposition, and that we will take the data set, and then it will have a matrix, and that we will try to use that SPD algorithm to identify user and summation parameter and value. This the three components you will get it. Okay, something like this. Say for example, if we send some data of matrix, something like that, it will give us three different matrix: U, summation, and V transpose. So as we have some values are less, if this value we can remove, and this value we can remove, and the same way we can remove this last one. So what will happen? This particular matrix is actually compressed into very small matrix. When you want to have this value, you just go to the third row and multiply all the components, you will get the original value. Okay, this way we will do the matrix factorization. So I show you that some SVD decomposition, and it's the original data. And after decomposition, after reconstruction, you will get the same kind of, more or less same value. If we then the learning is over, so we can use the small matrix to do the computation. Okay. And ALS is another algorithm which is we can do parallel implementation. This algorithms are available in our Spark framework. Now we want to understand how this ALS can be applied on the data set to give the recommendation. Okay. So now we will go back to our program. Here, this consists of the code. So here we are loading the data. The data is available, and here we want to separate the data into rating and then some user information. And here we want to configure the ALS algorithm, the rank and number of iterations is 10. And here we are train that algorithm using the model. Okay. It's something same as you already trained with, you know how to use KNN algorithm or any other machine learning algorithm. Same way, here we use this methodology to learn it. Then here we will test that algorithm, and the prediction we will try to predict the transactions. Now we will try to execute, and then we will see we can understand how it works. Yeah. So now we have some error. And okay. Now you know the logic how we will collect. Now we will try to collect the data. It says like user number 1 item, for item number 1 he gave the rating as 5. Okay, it's the original data. Now the user number 1 he gave the rating for the item number 2 he gave the rating as 1. Okay, let us see the ratings how it is coming. This is what I said. User number 1 he gave the product number 1 he gave the rating as 5. Okay, so now let us test data. You will try to understand the test data. We are passing the test data something like that. The user number 1, what is the rating he gave it for item number 1? User number 1, the same data actually we are passing same data as the test data. Okay, so here we want to see the predictions. Right. So now all the predictions came, and here now we are making that as a order list. User number 1, and for item number 1, what is the original rating? 5. So what is the rating we are getting it? The prediction. We are getting 4.99. Is it good?
Yeah, it's great.
Yeah. So the system is able to understand, and for third user for item number 2 he gave 5, and the system is able to predict as 4.9. So the system is now able to learn and understand what kind of prediction he will give to the particular item. So it now for the known data it's already learned, and if any new data is, if you are feeding any new data, what it will do? The system is able to predict what could be the rating he can give. If the rating maybe if he get a value say 4 plus, 4 and plus, what it mean? He will like it. Is my am I right? Am I giving you the idea? Now the system is able to learn for the given data, and it is able to understand what kind of prediction it can for the each and every item, what could be the rating he may give. If I give the new data, will it be possible for the system to learn it? Is it possible for that system to predict the new rating?
For new data, yes, of course.
Of course, yes. So that way, if we can set a threshold, say like if the prediction is more than 4, we can recommend the item to the particular user. That's the problem solved. It's a very basic idea to understand the recommendation system. Are you getting it? Okay. The same way here, I showed you some naive-Bayes algorithm, how to implement naive-Bayes algorithm for given data. For your understanding, this code you can download the code from the Spark page itself. Here I am showing you the k-means clustering algorithm and how that algorithm works and how that some squared sum error will be represented. So this way, I want to show how that SVM, I mean Spark works or Spark ML can be used to make use of our data and learn, and how big data analytics can bring in by using this Spark. Is there any doubt on this? Is there any doubt? Any challenge on understanding some of the topics? Is it good, bad?
Sir, whether that PySpark library has all the facilities for machine learning?
Yes. That only I used here.
Okay.
Here. This is a k-means available in MLlib. So I used here I used naive-Bayes. The same way you can find most of the algorithms. You can go here and you can find MLlib, machine learning library. You can find these algorithms: classification, logistic, regression, naive-Bayes, so and so, regression, decision tree. All these algorithms exist already. Okay, and you can go some examples. Few examples are here, and you can find code also available here. Some of the codes will be available. Not some, actually all the code you can download it. All the machine learning library you can use. Are you getting it? So here you can see the different machine learning packages, how to use it. Information is available here. You can go and spend some time so that you can get all this. Okay. So this is some of the publications I have in the recent months on rare attack prediction. Yesterday mentioned to you about a network intrusion detection system and how that how we can incorporate the recent of machine learning, deep learning algorithms into that. So some of the publications I have in that domain. Yeah, first one here it's a federated learning, and some of the rare attack prediction, future learning, zero shot learning, all these things are presented here. And all these things will be available in coming months. About 3 of them are already published, and 3 of them are in the pipeline. And these are the other publications. I just mentioned about the recommendation system. Nowadays, actually, we are incorporating semantic and temporal information in a sequential recommendation. The sequential is all about what will become next. That is the logic. And now we are developing a lot of continual learning framework. All the machine learning algorithms now, whatever you see is actually a static one. You will develop one time and then you will not retrain it. but actually we want to retrain each and every time. And the time of retraining the system, actually we will lose the existing things. So to avoid, we are proposing uh, a continual learning framework, so which is known as the ACL framework. And we are doing some activities with Japan, Nagasaki University on GAN method for segmentation and some advanced attention method for cancer screening. And again, Astra is one of the continual class incremental learning or continual learning method. The same way, here we propose another continual learning method for anomaly detection. And now we are proposing one rare attack few shot learning method for with the dynamic embedding C. So all these papers submitted, and then they are in the review. So hope all these papers will come in short. I request you to go through these papers. It's very recent, about 20-25 papers. You can refer those things and then enhance your knowledge. At the same time, I have some few openings in for PhD, and there are some possibilities for them to do get a dual doctoral degree, one degree from India, another degree from abroad. And if anyone, some of your friends, your student are maybe interested, then ask them to connect with. So thank you very much. If you have any doubt, you can make use of the another 3 minutes are there. You can ask me. Thank you.
Dear participants, does any one of you have any doubts? You can raise the queries now. Okay.
Sir,
On
how
behalf,
much time?
yeah. Yes, sir.
Sir, how much time it's going to take to do the current just now we have starting deep learning and everything machine learning, and how much time it's going to take to reach the level of current research?
Depends how much time you are
What are the
spending.
other things? What are the other things we need to learn?
Nothing, sir. You have to learn. It's a lifelong learning, and no one will be able to say I know everything. But it's a lifelong learning. Every day we have to learn, and then we have to upgrade ourselves. That is the way I can say. So there is no limit to reach that level, and no one will say I know everything. Today I can say I know something, but LLM came. If I want to see LLM, then I have to read it. And now agentic AI. So now I'm a no infant in agentic AI kind of concept. I'm learning it. So each and every day we have to learn, and always there will be a progress. So keep learning. And there is no need to compare yourself with anyone else. If you start reading it, if you upgrade yourself, then you will be master of that. So generally, it will take about 1 or 2 months to start, and it's a lifelong learning to learn. Lifetime.
Okay, sir. Thank you, sir.
So anything else?
Yeah. Okay, sir. Yeah. So I think I would agree with your statement. Being a teaching fraternity, it's a lifelong learning for all of us to stay in touch with the latest technologies. I would agree with your statement, sir. And now, on behalf of the St. Peter's College of Engineering and Technology and the departments of AITS and the departments of AITS and Information Technology, I would like to sincerely thank Dr. Syed Ibrahim, Senior Professor at VIT University Chennai, for giving us an excellent session on big data, Hadoop programming, MapReduce, Spark, and the recommendation systems. Sir, as usual, your explanations were very clear, and the live samples codes that you have executed has given us a very good understanding. And we really appreciate the way you have patiently addressed all the doubts and the questions of all the participants and how you have cleared their doubts. So your teaching was really quite interesting, and we have also increased our, I would say that all the participants would have definitely have a very good, would have developed a very good interest in Hadoop, Spark, and the recommendation systems, and would really carry out with what you have taught to take it over to their research and projects. So we are truly grateful for your time, guidance, and the valuable contributions that you have given to this FDP, sir. Thank you once again for sharing your knowledge with us, sir. Thank you, sir. Thank you.
So thank you very much for your support as well as the opportunity given to me. I'm grateful that about 127 participants here, and I share my knowledge with them. And again, it's again lifelong learning. Even my method, my machine learning methods also now we are making it into lifelong learning by making it the continual learning methods. So even I said that the learning, whatever the current technology, current learning algorithms, they will stop learning after some time. After model building, they will not learn it. So that is a disadvantage. We are seeing it. We want to make that as a continual learning methods. That also there is a continual learning and lifelong learning. Keep learning. And thank you very much for all your wonderful support and your patience listening on my lectures. Thank you.
Thank you, sir.
Thank you, sir.
Great future, sir. Thank you. Yeah, dear participants, we will now give a small pause and get connected at 7:45 for the next session, the 10th session. And we'll join back. Yeah, please join back at 7:45. And I would like to give a reminder to you that tomorrow we are starting our sessions are starting at 2 o'clock in the afternoon. And the sessions will go on till 6:30. And after every session, the feedback links will be shared, unlike how it has happened the 5 days. So these 5 days, we have shared you one feedback link, but tomorrow we will be sharing them for all the 3 sessions separately. And your evaluation or the test link will be shared at 6:30. So I just want to keep you informed. So stay updated with these and ensure that you get connected with us at 2 o'clock tomorrow. And we'll have a small break and connect again at, we'll come back at 7:45.